example. Or it can be done using another way, where mainly people today do in technique is, you have the aperture which is very small, so whatever light comes out from the aperture is an evanescent wave. So then you will be able to break the resolution barrier and you will be able to go to sub-wavelength regimes. Typically, resolution is to 10 to 12 nanometers. In principle, it can be done. So the ENSOM we have is the latest state-of-the-art ENSOM provided by Nanonyx. It has both an upright microscope as well as an inverted microscope at the bottom. So you can collect light through reflection mode as well as in the transmission mode. And you can do fluorescence, photocurrent, all can be done using this. And we have two probes which can be close, or which can come close to around 50 nanometers within them. And then you have these probes are optical cantilevers which are tethered to a tuning fork. So you do have a feedback mechanism, where the tapping mode feedback mechanism takes place, and then you will be able to control, or you will be able to map the morphology. And with the optical cantilever coming, you will be able to do the optical also. This is a typical image of our probe. You see that the tip is here and the light is coming out. This is when it is out of contact. When it is in contact, you will not be able to see the light coming out. So, in the previous talk, Dinesh talked about layer by layer assembly very well. I have also used the similar measurement. Instead of using a polystyrene bead, I have just used a glass substrate, and on it I have done the surface charging. And then depending on what my substrate is, either I want to add polycation or polyanion, I charge it positively or negatively. So I can absorb both polycation as well as polyanion. This will be important, and this I will explain when I come to the next slide. BR basically has a negative charge on one side of its polymer, one side. So when you have the substrate positively charged, then you can absorb BR easily onto it. And when you do an UV spectra, you see the absorption maximum corresponding to 580 nanometers. And when you go back and calculate using Beer-Lambert's law, roughly you get around 20 nanometer thick films. Okay, so now I have these thick films. So what do I